All right, welcome to part 2 of fractions. So on this video, we're going to deal with multiplication of fractions, division of fractions, what are equivalent fractions, how do we determine equivalent fractions, percentages. We will deal with what? Fractions as percentages, changing percentages to equivalent fractions, and percentage increase or decrease. And last but not least, we will also simplify square and cube roots. So let's start. Multiplication here. So here on A, we are given multiply 3 over 4 by 2 over 5. This is a simple thing. What do? We write our equal sign. We say 3 multiplied by 2, it gives us 6 over 4 multiplied by 5, it gives us 20. 6 over 20 is the answer that we got. Now we have to ask ourselves, remember we have to simplify. Is this the simplified version? Mean to say that, isn't there a common factor that can divide 6 and 20 besides 1? So the answer is, yes, there is a number that can divide 6 and 20. That number is 2. So we come here, we divide by the conjugate of 2 over 2. 6 divided by 2 is equal to 3 over 20 divided by 2, it gives us 10. Besides 1, is there any other number that can divide 3 over 10? The answer is no. So this is the simplified version. 3 over 10 is the final answer. All right. Now, B, we've got a different variation of multiplying fractions. What do I mean by that? Check. We've got a common fraction here as well as a mixed number. So what do? The first order of business is to rewrite 2 over 5. So we rewrite it 2 over 5 multiplied by. Now we have to convert this mixed number into an improper fraction. So 4 multiplied by 2, we're saying the denominator 4 multiplied by the whole number. 4 by 2 is 8 plus the numerator 9. So I've got 9 over 4, which is equals to. Now when we're here, we now say 2 multiplied by 9, which is equal to 18 over 5 multiplied by 4, which is equals to 20. Now we ask, is there any common factor for 18 and 20? The answer is yes. So we say divided by. Which number we're going to be using here? In this particular instance, we're going to use number 2 again. So we say 2 over 2 is equals to 18 divided by 2 is equal to 9 over 20 divided by 2 is equals to 10. 9 over 10. And this is our final answer. Right? Then we go to letter C. 2 over 3 off. The moment you see the word off, you must know that it means multiply. So we are going to say 2 over 3 multiplied by 4 over 5. 2 multiplied by 4 is 8 over 3 multiplied by 5 is equals to 15. And other than 1, there is no other number that can divide 8 and 15. So there we are done. All right. Here now we're being told 6/5 of 50. This is a whole number. So we need to write it as an improper fraction. So we say, okay, we have what? 6 over 5. Let me write it here. 6 over 5 of, remember I said it means multiplied by. So I multiply by 50 over 1. Now there is another method which I could have used for all these 3. I'm going to introduce it here. What happens? I can look at the numbers that are across each other and find if they've got a common factor. I've got 5 and 50. If I say 5 into 5, it's 1. 5 into 50, it's 10. Now what do I have? I have a numerator multiplied by this numerator. 6 multiplied by 10 is equal to 60. Over 1 multiplied by 1 is equals to 1. And 60 over 1 is equals to what? 60 whole numbers. So this is the answer, 60. All right, we're done. So 6/5 of 50 is equals to 60, but you must show your calculations. So that's the different forms of multiplying fractions. Now we're going to focus on what? Division of fractions. Now on division of fractions, there's a method which we use, which we rely on, very reliable method, which is called keep, change, and flip. Let's see how it works. Here I've been given 5 whole numbers and I've been asked to divide by 5 over 7. So I come here, I start off by writing these 5 whole numbers as an improper fraction, so I write 5 over 1. When they said keep, the number which is always to the left of the division sign, you always keep it, you don't change it. Now they said change. What are we going to change? We're going to change the division sign. Whenever you say division sign, you must know after writing keep, the next thing you must change. You change what? The sign. The opposite of division is multiplication. So we write multiplication here. So done with change. Then the last part is flip. We are now going to flip this fraction, meaning to say the denominator becomes the numerator. 7 is our numerator and 5 is now our denominator, which is equal to. You have 2 methods. You choose the one which you're comfortable with. So now I'm going to say 5 multiplied by 7, which gives me 35, over 1 multiplied by 5, which is 5. Now, obviously, 5 can divide 35. 35 divided by 5 is equal to what? 7. If you do not know your multiplication board, just put it into the calculator. The calculator will give you the final correct answer. We move on to the next question, where we are told that 6 divided by 1 and a quarter. Now, we've got a whole number and a mixed fraction. So we say 6 over 1, we've kept it. Now, we must change. We change the sign to multiplication. Now, before we flip, we can't flip this. So, we have got 4 multiplied by 1, which is 4. 4 plus 1 is 5. So, 1 and a quarter is equals to 5 over 4. But here we have been asked to flip. So I can't write 5 over 4 here because already I've changed the sign. What should I flip? I must flip 5 over 4, which makes it 4 over 5. So I come here and I write 4 over 5 like that. Now I flipped. Now, what am I going to do? Numerator multiplied by numerator. 6 by 4 is equal to 24. Over 1 multiplied by 5, which is equals to 5. Now, I say 24 divided by 5, which is literally 5, 10, 15, 20. 4 whole numbers and remainder 4. So 4 whole numbers and 4/5. And this is the final answer. Now we go to letter C. So these are different variations, by the way, in case you haven't noticed. I have written 3 different variations of how to divide fractions so that nobody can be alarmed in an examination. Here we are given a common fraction and a mixed number. Maybe let's use an alternative method, whereby I'm going to say 9 over 11. I repeat it. Then I'm not going to change anything. So I repeat writing the division sign. What am I going to do? I'm going to change this. So I say 3 multiplied by 2, which is 6. 6 plus 2, 8. I've got 8 over 3. Now, on the next stage, I'm now going to use my reliable friend called keep, change, and flip. What am I keeping? 9 over 11 over. I'm changing the sign from division to multiplication. And then I must flip 8 over 3, which now gives me 3 over 8. On the next stage, now what am I going to do? What I'm going to do now, I'm going to multiply numerator by numerator. 9 by 3 is equal to 27 over 11 by 8, which is 88. Do I have a number that I can use for 27 and 88? If I use 3, it's 9. But if I use 3 here, 3 is 6, but into 28, I don't have. So I can't use that. I can't use 2, because 2 works with 88, but it doesn't work with 27. I can't use 4. 4 works with 88, but doesn't work with 27. 5 doesn't work for both numbers. 6 doesn't work for actually both numbers. So I think 27. How about 88? It doesn't work because 9 by 9 is 88 and 9 by 9 is 81, sorry. 81 plus 9 is 90. So we just leave it like that. 27 over 88. Then we go to the last one in terms of division. We've got 5 over 2 divided by 1 over 2. Right? So we have an improper fraction and a common fraction. We keep 5 over 2. We change the division sign to multiplication sign. and then we flip, which is now 2 over 1, which is equal to 5 multiplied by 2 is equal to 10 over 2 multiplied by 1, which is equals to 2, and 10 divided by 2 is equals to 5 for all numbers. And just like that, we are done with the division of fractions. Now we move on. Let's check our guidance. So far, multiplication done, division done. What is next? Equivalent fractions. When we're talking about equivalent fractions, remember we're simply saying that which fractions are equal to each other. So for instance, if you are given what? Equivalent fractions. So if you're given 7 over 10, then they ask you which other fraction is equal to 7 over 10. Very, very simple. I'm going to come and multiply with my conjugate. 10 over 10. 7 multiplied by 10 is equals to 70. Over 10 multiplied by 10 is equals to 100. I got 70 over 100. On the first video, I explained the work of the conjugate, so I'm not going to re-explain it. If this is your first video, please go to the part 1 of fractions, and you'll see I explained in detail what is a conjugate and how it works. All right. So in other words, they asked for the equivalent fraction of 7 over 10. So now I conclude that 7 over 10 is equal to 70 over 100. Right? Done. If I had been given 2 over 3, then they've asked for the equivalent fraction. I could have just come here and simply say 3 over 3, my conjugate. I say 2 multiplied by 3, that is 6 over 3 multiplied by 3, which is equals to 9. So I now write 2 over 3 is equals to 6 over 9, like that. So I say 2 over 3, I multiplied by the conjugate 3 over 3, and then I say numerator multiplied by numerator 2 by 3, which gave me 6, 3 multiplied by 3, which gave me 9, and now I've concluded that, therefore, 2 over 3 is equals to 6 over 9. So there isn't much to the work of equivalent fractions except that they're asking you for fractions that are equal to whatever fraction that you may be given, right? So we are done with equivalent fractions. Now we are going to work with what we call percentages. But what a person needs to understand before we go and explore percentages is to understand what are percentages. Remember, we said fractions, we are dealing with part of a number, right? So if I'm given a one whole number, let me represent it with a drawing. I'm given this bar, and they're saying that this is one whole number. Now, what happens with percentages? Now we're simply saying that this one whole, you must divide it into 100 equal parts. 100 equal parts. So you must fill it out. Right? So when you see the word percentage, you must know, or when you see this sign, this is the sign or the symbol for percentages, you must know that it has been divided into 100 equal parts. Right? So those are percentages. Now, under percentages, what did we say we're going to start with? Fractions as percentages. Fractions as percentages. So let's come here and we say that we've got 2 over 5. They want 2 over 5 as a fraction. And the 2 over 5 is the fraction. They want it as a percentage. And because everything is divided by 100, we come here and we multiply by 100 over 1. Now we say 2 multiplied by 100, which gives us 200, all over 5 multiplied by 1, which is equals to 5. Now we've got 200 over 5. Then we now say 200 divided by 5, right? 5 into 5, it's 1. 5 into 20, that's 4. 5 into 0, that's 0. 40. But the answer that we got, because they said they wanted what? They said fractions as percentages. We now use this sign. So it's not 40 donkeys, it's 40%. So you must use this symbol to represent the percentages. Failure to do that, it means that your answer is wrong. Let's look at another fraction. Let's look at number 1 over 8, an eighth. So we have given 1 over 8. They want it as a fraction. We now say 1 over 8 multiplied by 100 over 1, which is equal to 100 multiplied by 1 is equals to 100 over 8 multiplied by 1 is equals to 8. Now, we say 8 into 8, that's 1. 8 into 10, that's 1. Remainder, 2. So we put a 2 here. 8 into 20, that's 2. Remainder, 4. 8 into 4, we can't. So what should we do? We should borrow a number that we don't have. The moment we borrow a number that we don't have, which number are we going to borrow? We're going to borrow 0. So now we've got 40. The moment we borrow a number that we didn't have, then immediately we write a comma. Now we say 8 into 40, that's 5. Pause 8, 16, 24, 32, 40. Now, 12,5 is the answer that we got. But those are not cows. 12,5 what? Percent. Right? So this is how you write your fractions as percentages. So, done. Now, they are saying we must change percentages to equivalent fractions. So, how do we change those percentages into equivalent fractions? All right, let's explore these the numbers that we've been given. We've been given which percentage? 42%. Okay. So we were given 42%, and they want this 42% to be written as an equivalent fraction. So remember what happens. When you have got 42%, we said that it means this has been divided by 100. So in other words, we're having 42 over 100. When you see 42% as a fraction, this is 42 over 100. So we know that 42 over 100 is 42%. But the question is asking for the equivalent fraction, meaning to say that which other fraction is equal to 42 over 100, right? So now observe, 42 and 100. What do we have? We have got numbers that are common. So I come here and I say divided by, and divided by. I must divide by a conjugate. Now let me ask myself a question. If I'm to use number 6 into 42, it works, it's 7. But 6 into 100, 6 into 10, it's 1 carry. For 6 into 40, it can't. So let me try which number? Which other number can I try? I can't use 3. Let me try number what? Number 2. So I divide by 2 here and I divide by 2 there. 4 divided by 2, that's 2. 2 divided by 2, that's 1 all over. 100 divided by 2, that's 50. Now I've got 21 over 50. In other words, 42 over 100 is equal to 21 over 50. So I have found fractions which are equivalent to 42%. That's what I do. That's what we do. So the moment you see this percentage, you must know that everything is over 100, right? Let's explore another question with regards to this. Now this time around we are given what? 118%. 118%. So we come here and we say we have 118%. They've asked us to represent this as a fraction, but not only one fraction. We must find the alternative or the equivalent fraction. So first thing that I do, I say 118 over 100. Why? Because this symbol tells me everything is over 100. Now, what am I going to do next? I know that I'm going to divide. Why? Because there is a common number for 118 and 100. So right now, because these numbers are bigger, let me just use number 2. I say 2 divided by 2. Now, 2 into 11, that's 5. Carry 1. 2 into 18, that's 9. If you're not good with numbers off the top of your head like me, you just go to the calculator and you say 118 divided by 2 to give you 59. And you say 100 divided by 2, which will give you 50. Right? Now we've got 59 over 50. These numbers, do we have anything which can be equivalent? I don't think so. Right? So in such a case, if I'm having that, then I can simply take 118 over 100, and I say 118 over 100 is equivalent to 59 over 50. There is no other number that I can use, right? Or alternatively, what can I do? I can say I've got this 59 over 50, which I got when I reduced this 118 over 100. I can come here, instead of multiplying this by 2, because remember here I divided by 2, I can actually multiply this by 4 over 4 and say 59 by 4. Now that's 118 times 2, which is what? 336, if I'm not mistaken. 6, no, I'm mistaken, actually it's 236. So I've got 236 over 50 by 4, that's 200. If you punch 236 over 200, definitely I know that either it will give you 59 or it will give you 59 over 50. So just like that, that's how we determine equivalent fractions when you've been asked to change percentages to equivalent fractions. Now, the last part in terms of percentages, it talks about percentage increase or decrease. What happens with this particular question? What they're simply saying is that you have been given a number, now increase that number, right? So let's look at, I'm just looking for a question here. All right. They said increase 120 by 10%. Increase 120 by 10%. What happens? Now what happens is this number 120 as a percentage, it is equals to 100%. Right? Now I'm being told I must increase this 120, meaning to say I must make it bigger. By how many percent? By 10%. So in other words, there is a new figure here that I do not know. But in terms of the percentages, I know what's happening. The 120, I know that it's 100%. And the 10%, they've said that I must increase this 120 by 10%, which means that whatever this figure is, I must increase it by 10%. And when I say 100% plus 10%, it gives me 110%. So whatever this number is, as a percentage, I know that it's 110%. So instead of putting a question mark, I'm going to use what? I'm going to use the letter X here to represent this number, right? So what's happening? Now I'm simply saying, oh, I'm being told I've got 120, right, over what? Over X. Why? 120 is a number, X is also a number. This number is bigger than 120, even though I do not know its value. Now I come and I say I'm multiplying by. Now I've got 120. Remember 120 as a percentage, it's 100%. So here I've got 100 all over. What do I have? I have 110%. This is the X, 110%. Now what am I going to do? Now I can simply come here and say 120 multiplied by 100, or I can use an alternative method whereby I know that mathematically, if I've got a 0 here and there's a 0 there, these two, they can be equal, provided that here I've got hundreds, tens, and units, and there I've got 100, tens, and units, so they should be equivalent. So I'm now going to say 0 cancels that 0. So I'm left with 10 over 11. Now I say 120 multiplied by 10, which gives me 1,200 over. Now I say 11 multiplied by X, which gives me, I think I made a mistake here. Yes, I made a mistake. I made a minor mistake. Let me fix it. So here where I placed the equals, the multiplication sign, I was supposed to place an equal sign. In other words, I'm supposed to have what? 100 over 110. Now these two are supposed to cross multiply, meaning to say that now I've got what? I've got 120 multiplied by 110, which is equals to this X multiplied by 100. x multiplied by 100. So now I've got 120 multiplied by 110 and x multiplied by 100. So what am I going to do? I'm now going to say 100 by x, it's 100x. And using my calculator, 120 multiplied by 110, so 120 multiplied by 110, 13,200. So I've got 13,200 here. Now I divide by 100 so that I can find x. And what I've done on the right hand side, I must do on the left hand side. I divide by 100. 100 into 100 is 1. So I come here and I say 100 into 100 is 1. So 1 multiplied by x is x. So I say therefore x is equals to 13,200 divided by 100, which is 132. So x is equals to 132. And remember, like we said, 110% is bigger than 100%. So the answer that we got of 132, it is bigger than 120. So of course we have increased it 10%, right? But this is method number 1. The very same question, we could have dealt with it differently. Now, they say increase, the question is still the same, increase 120 by 10%. So what could I have done? I could have come here and said, what is 10% of 120? So I say 10% of 120. I cancel this 0, it cancels that 0. I cancel this 0, it cancels that 0, which is equals to 12. But they were not asking for 12. They said I must increase this number. Now this 12 which I got, now I say 120 plus the 12. I put this into the calculator, it gives me 132. And you are done, right? So that is when they talk about increase percentages. This is what they're talking about. Then from there, they can ask you to what? To decrease. So when they use the word decrease, they're simply talking about reducing. So in this particular instance, they've said that decrease 2,500 by 7%. Decrease 2,500 by 7%. In other words, we're simply saying, let's first find the 7% of 2,500. So we say 7 over 100. Where's the 100 coming from? Remember, percentage means it's over 100. Multiplied by 2,500. I have 2 zeros, I see 2 zeros there. These two, they cancel. Now I'm left with 25 by 7. 5 by 7, 35. 5 carry 3. 7 by 2, 14 plus 3, 17. I've got 175. So 7% of 2,500 is equals to 175. But they were not asking for 7%. They are saying that I must decrease it. So now I come and I say 2,500 minus 175. Remember, decrease means reduce. 0 minus 5, it can't. I must borrow from here. But this doesn't have anything. So I must borrow from here. So now I'm left with 4. Here there's 10. But the reason why this one borrowed it because it wanted to help this number. So I now remove 1. I'm left with 9. And here down left got 10. So now 10 minus 5 is equal to 5. And 9 minus 7 is equal to 2. 4 minus 1 is equal to 3 and 2. So when you reduce 2,500 by 7%, the number that you get is 2,325. And I think for your grade, this is better method than the other one, which I could have alternatively used, right? So, yes, this was the last part in terms of the percentages. Now we go to the last one on this particular topic of fractions, right? What are they now saying? Here we are being asked to simplify square and cube roots. Square and cube roots. So, for instance, we are given the following number, right? We are given a number square root of 4 over 9. So we're given square root of 4 over 9. like this. Now they're saying that we must what? Simplify, meaning to say that we must leave it in the simplest form, whereby 1 should be the only number that can divide the numerator and the denominator. So when you are given this, the first order of business is to come here and say that they are asking for the square root of the numerator, so square root of 4 over square root of the denominator, square root of 9. And if you do, you go to your calculator and you press square root of 4, this is a square root of a perfect square, which is 2 over square root of 9, which is 3. This is the final answer, right? All right. Then, cube roots, right? So, you're given cube root of 8 over 64. What does it mean? The first thing that I'm going to do is that I show that I'm looking for the cube root of the numerator, which is 8, over the cube root of the denominator, which is 64. Now, when I ask for the cube root of 8, it is equals to 2 over, please punch your calculator, and then cube root of 64 is 4. So, I have 2 over 4. But is this the simplified number? The answer is no. So what should I do? I must reduce it. I divide by 2 over 2. 2 divided by 2 is equals to what? It is equals to 1 over 4 divided by 2 is equals to what? 2. So I've got 1 over 2. Right. Good. So I know this video was a little bit longer, but everything is worth it. And if you follow everything that I've taught you in this video, in your examination, you shouldn't have any problems. So on the next chapter, on the next video, I'm going to be dealing with what? I'm going to be dealing with whole numbers. And I will explore the entire subtopic of whole numbers. Actually, the entire chapter on whole numbers. So at this point in time, I would like to say that if you found this video to be very helpful, please consider subscribing or share with your loved ones as well as your classmates. Please do not remember, when you've subscribed, turn on the notification button. And if there's a topic that you want me to help you with, use the comment section to put your request. And most importantly, please do not forget to like the video. Till we meet on the next video, for now, cheers.